And we continue doing the piecewise function. Remember, piecewise function is a function que is defined a little bit weird. It defines in different pieces, one piece, two piece. Let me using another color for the second piece. Maybe red. And each piece is defined. For example, this piece, que es expression, no? Algebraic expression, is valid for this condition. Gray, gray, and red, red. But the problem now, we discussing last time, no? This idea, the interpretation, this. Now, the problem now is just doing the graph of this. So this is the reason I have here the rectangular coordinate system, because I want to practice how we can do the graph, this piecewise function on the rectangular coordinate system. Okay, this is super easy. Look, you take the first expression. Okay, is this. Okay, is y equal x plus 2. And you are doing the graph of this. You ignore the rest. So this is a line you know very well. Remember, we compare with if y equal mx plus b. You know very well b is 2, m is 1. Therefore, the y in the set is the point 0,2 because b is 2. And I plot that point. Boom. 0,2. And the slope is 1. Therefore, right and wrongs, suppose that everyone remember very well this idea, is 1. To get the second point, from this point you're moving 1 over 1 to the right, you obtain the second point, and we connecting both points by the straight line. And this is the fantastic way to plot the linear equation, no? Equation of the line. 45 degree, I guess so. 45, 45, 45, 45. Because the coincidence is one slope. And we are doing the graph of this. And this is the graph of the our problem. No, this is one piece. It's the graph of the one piece. Now the graph of the second piece, because we have two pieces, is you take the second piece, que is this, y equal 4. Oh, it's a constant function. It's a constant. And a constant function represents the horizontal line. And the horizontal line passing through 4 is, 0 degree, 0 degree. Okay, and it's a constant function. It's 1, 2, 3, 4 over there. So this is the graph of the second piece. Now, so far we are doing two graphs. The graph of the first piece and the graph of the second piece. But my goal is do the graph of the piecewise function, the entire piecewise function. Now I can see the conditions, okay, the transition is the technical name of the condition is in 1. So when 1 happens, before 1 happened one situation, after 1 happened another situation. Therefore, x equal 1 represent the vertical line 90 degree passing through 1. So we have 90 degree and 1. Okay, let me using in this case dotted line. Let me change the color to maybe blue to differentiate. And we are doing in black color the graph of each piece separately. Now this dotted line, is by the way split the plane in two semi-planes, generate somehow the interval less than or equal 1, que es from 1 to the left, and greater than 1 gets from 1 to the right. In this case, equal corresponding with the first interval, but it's not important. Now, for a moment. Now I am ready now to do the graph of the piecewise function. Let me use another color, maybe red color. Or let me try, yeah, red color. So now, look. Before 1, the piecewise function travel for the x plus 2, que corresponde with the line, the inclinate line, the oblique line. Entonces es the graph of the piecewise function. I try to do by hand, guys. However, after in few seconds, I want to explain how you are doing the same job, super easy and Desmos. But okay, by hand. So now, actually, the graph of the piecewise function travel for this line to 1, and 1 is stop. Why stop? Because we change to the another piece after greater than 1. We change to the piece 0 degree horizontal line, travel for this. We almost finish. You see in the red color, we have the graph. This is continue forever, and this is continue forever. But important. In the transition point, we always put 2 circles. And we have 2 kinds of circles, circle closed or circle open. How do you know when it's open? How do you know when it's closed? You look here at the equal sign. Equal sign is in the first piece. Therefore, the circle closed is in the first piece. And in the second piece, no equal sign. That means you do not include that piece in 1 specific. After the 1, yes, but in 1, no. Now, the symbolic way to indicate this idea is using circle open. Cool? Everyone understand? And the rest, if you want, you take the eraser and erase, because the rest was just auxiliary construction que help me to get this answer, que es the final answer. Cool?
Yes.
Now I want to repeat again this endesmos. And you see it's super easy. Remember, I don't care that we are living in the 21st century, and the application for the software is extremely important in the teaching of mathematics. So now, bueno, in the 20th century or before, we are doing everything by hand because we have no internet, we have no technology. Pero no, in this moment, no. Okay, so let's do the same problem, but using this one. Let me switch in the screen for Desmo. Let me share. Switching Desmo. Now I suppose you can see Desmo. Yes or no?
Yes.
Okay, so it's easy. Let me show you. You here, you need to be strong. So little by little, guys, you learn more about Desmos. And this is fantastic and easy tools because it's very intuitive. So you don't know anything, but you try. If it doesn't work, no problema. Okay. Now look, you put the first piece of the piecewise function. I like so much using the keyboard, specific keyboard for Desmos. So you put x plus 2, x plus 2, bam. This is a line. But the problem is, okay, I have condition, and the condition for this, you open this curly bracket and you put x less than or equal x less than or equal 1. And you see the piece que we are doing by hand, but you see exactly not the total line. You see the piece que corresponde from -1 to the left, que es this condition. Now, the second piece. Oh, the second piece is a constant function, que es 4. And constant function is, well, y equal 4, no? Let me see, y equal 4. There you go. It's a horizontal line. But this horizontal line is, you put a condition, using the curly bracket, the condition, and this is for x greater than 1. Bang. Okay, now we have approximately, let me use the same color because this curve is two pieces, pero of the one mathematical object. Entonces I suppose que I like so much the blue color maybe. You press this icon and change the color. Bang. Okay, now the rest is extremely important is the point. We have 2 points. One point is located at the point 1,3, I guess so. 1,3. We're using your imagination and you look in the picture. And the picture I saw clear que 1,3, right? And 1,3 blue color, let me change the color. And you can change the style of the point. If you want the label, you put the label. But no. Now this is close, and close is a solid. And we have another point, que is the point 1,4, no? 1,4, 1,4, 1,4. Right, I don't know exactly what's going on. 1,4. Okay. 0,4 again, blue color, no purple color, no blue color, because belong to the same. But the style is open. And this is fantastic answer for this. Do you think it's super easy? Do you like? All right, show me. Emily, you say yes. Okay, so now you know very well. In the test, you can generate. There are many ways to make screenshot. Okay, but okay, Desmos allow you here, I suppose, or here, I don't know. No, here. Share the graphic. So you generate a picture, export a picture. Bah! And this picture you attach to the written text. Cool? You click here. I don't want to do, you download this picture. You using different style. No, I like that. And you, for example, this is okay for me. You click here, download, and that's it. Any question? Let's do one more. Let's do one more. I will come back again to the whiteboard. Let me try to share whiteboard. And let's do one more example of the piecewise function, of the graph of the piecewise function. And the test you see two questions about piecewise function. One is evaluate. Evaluate is super easy. Another is graph. So, basically, I'm training to you now to make a graph. Okay. Suppose another piecewise function, a little bit more complicated. Okay, suppose that f of x equal, you open the famous curly bracket, big. It's a symbolic way to indicate piecewise function. And what is x squared? It's my first piece. And this piece is valid if x is in between -2 and positive 2, including both endpoints. Okay, remember the typical format is the expression and is conditional. in which is valid this. Outside this, no. And the second is 2x minus 1 if x is greater than 2. We have again, we have condition and expression in which is valid this. Okay, let's do it. The first interval is from -2, look, okay, -2 and +2. This is my first interval. This is this. Entonces, in this interval, we have a parabola. This is a parabola. It's quadratic function. Entonces, en 0 es 0, you know, 0,0. And 1 is 1, so in 1 and -1, so we plot different point mentally, and 2 is 4. Okay. And this is my piece of parabola. Look. This is my piece of parabola. Okay. After I care the endpoint. This is the graph. This is the graph of this. Okay. Now let's do in the graph of this. Can look like a line. Y equal to x minus 1. I see que b es -1, que representa y intercept, and slope es 2. Entonces, I plot the famous point 0, -1, que represent the y-intercept of this line, is here. And using slope 2 is 2 over 1, 2, and 1 to the right. Therefore, my line, I get the second point, and 2 points is enough to do the graph of the hour line. Okay, let me try here, over there. This is the line. I did the graph of the expression. This is the expression. Y equal to x minus 1 in black color. However, in red color, I did the graph of the expression y equal x squared. Now put together in the logical way and do the graph of this. Okay, basically the domain of this function start in -2, of course including -2, to infinity, because the second piece continues forever. Entonces, before -2 we have no. Entonces, now let me use another color, maybe the blue color is the final answer. So we start here. This circle is closed. This is the parabola. 2 positive 2. And this is also closed. So we did that part. Now the other part is line start in 2, but in 2 case this is open because no equal, and continue forever in that direction. And the rest you can delete. No important. The blue is the only important. Okay, the blue, the red no. The blue yes. And this is the graph of the piecewise function. Of course, doing by hand. No, it's no big deal. But it's okay. Let me try in Desmos now. Do you follow me? It's easy or no? Okay. Now Desmos. Let me switch to Desmos. Desmos. Do you see Desmos?
Yes.
Okay. Now let me organize this. One more time, I want to explain how. Look, I click here in the plus sign, and you select folders. And inside the folder, you put inside the example number 1 pieces, and you put a name. Maybe example 1. And you condensing inside. Yeah, put together inside, and you put on enable, because I want to create another folder to the example 2. The name, now little by little, you put the pieces. And the piece 2 is x squared. Y equal x squared. You can write y if you want. If you don't write y, that's most default understand case y. But I like x squared. Look at that. Boom. It's a parabola. Look. Now you put a condition. The condition, you open the curly bracket. This parabola is in between -2 and +2. Okay. Let me use in the blue color. Remember, I'm using the blue color, but using the color you prefer. This is one piece. I did the graph of the one piece. Let's do in the graph of the second piece. The second piece is a line. It's a line que es equal y equal x minus 1, no? Minus 1, minus 1, minus 1, minus 1. Okay, cool. The same color. The same color. Let me change the color. Blue. And don't forget the condition, the restriction, the condition, que es curly bracket x greater than 1, ¿no? No, 2, 2, 2, 2, 2, 2, 2, es 2, ¿no? Es 2, ya. X greater than 2. Boom. To finish that, we put the point. The point R. We have two kind of point que is close, and we have one point que is open, no? The point que is close was the point -2,4. Bang. And the same category que is close is the point 2,4. Positive. However, not necessarily doing no. In another line, another row, we plot another category que is the point que is open. Que by the way is the point 2,3. Let me show you. Let me see. 2,3, 2,3, 2,3. Again, same color blue, but the style is different. It's open. Boom. This is my final answer. Beautiful. Any question, guys? Do you understand or no? I promise in the review package, we practice. I will show me. Emily said yes. Okay, Emily. So now, I want to spend the time. You condense in this, you erase, and you say if you want. And then you put I don't know, the name. Okay, let me come back. I'm recording? Yeah, I am recording. Okay, let me come back to the whiteboard. Whiteboard. Okay. Whiteboard now. Okay, we study another topic. It's the last one. Que is another way to combine functions. I want to call combination of functions. Now remember, in this chapter we study functions. After we study one possibility to create family of the function using transformation. Secondly, now we study piecewise function, que is the function formed by different pieces of functions. Now we study combination of the function. Combination. Combinations of functions. There are many ways to combine a function. However, the most important is the classical arithmetic operation. We have the sum, addition. Suppose we have at the beginning two functions I want to call f of x and g of x. It's the name of two functions, and you put together like that, f of x plus g of x. And the symbolic way to indicate this is open the parenthesis f plus g of x. This is symbolic. When you see that, you understand very well get the sum. Now the difference of subtraction is f of x minus g of x, for example, or in other order is f minus g. This is minus of x. Okay, now the product is multiplication. Is f of x times g of x. And the symbolic way to indicate is f times g parenthesis of x. And the quotient or division, the quotient, que is division, is f of x divided by g of x. And the symbolic way to indicate this idea, open parenthesis, f division g of x. This is the symbolic way. This is super easy. This is not important. Now, the complicated part is determine the domain. Determine the domain. Because we are strong, or if we are not strong, we practice in the review again, how you determine the domain of the only one function. What is the challenge now? Determine the domain when you have two functions or three functions using different arithmetic operation. But the formula is easy. The formula is, look, the formula is for this, and this, for addition, subtraction, and multiplication, the domain of the function is the domain of f intersection domain of g. This symbol indicate, remember, this look like a U inverted. This is union, but this is not union, this is intersection. Intersection. Okay, if you don't like this symbol, it's okay. You put and, que es synonymous. No? And, remember the compound inequality when you study compound inequality. So you need to satisfy the condition for the domain of f and the condition of the domain of g. And when you're talking about and, it's because if at least one failed, it's completely out of the domain. No? However, and the last one is similar, the domain of f intersection domain of g is same, but you include a extra, que es when the g expression is non-zero. Okay, because you know it's totally illegal division by zero. Okay, this is theoretical part. Let's see one example. Easy, no big deal. Now, after we see one more thing, one more combination of the function, not only addition, subtraction, multiplication, and division, we have another operation more complicated, but very important. Suppose example one. Let's do a couple. Is suppose que two functions is given. And g que is x over x plus 2. This is what's the question. The question is determine what is the expression of the f plus g of x determine expression. This is my first question. And my second question, always in this kind of problem, is state is domain. So it's no valid. So you are doing the algebra part to determine the expression, but you need to present the function, the new function. But what is the domain? The domain. So you state is domain. This is the most, well, not complicated, but it's the most, yeah, complicated part. Okay, let's do it. Let's do it because it's easy in this scenario. Look, the expression is you put this and this together. It's 1 over x plus 3 plus x plus 2. You can leave it like that. Well, you can. However, it's not polite. It's much better when you have two fractions. You condense in this fraction in only one. So you find the least common denominator. Guy, I suppose that you know that. Remember, this is intermediate algebra. Okay? I know that my student in the other class very well know this. LCD is together x plus 3 and x plus 2. And the top part is easy. You divide this divided by this. It's obvious x plus 3 is cancelled, division. And stay x plus 2 alive multiplied by 1 is x plus 2. Plus, and the second fraction, exactly the same. You divide this by this, x plus 2 is cancelled. Stay alive, x plus 3 times x, que es the corresponding numerator. Almost I finish. The only thing I should do is apply distributive property in the top and combine later. X plus 2 plus x squared plus 3x. Okay, cool. Let me combine right term. The only right term is this and this together. This is x squared plus 4x plus 2. If you want, I erase that part and you replace by this. And this is, you can do another operation you find here, but no. Either way. Then this is my final answer. This is expression okay, corresponding with the combination of the function f plus g. Okay. Now domain. Oh, domain is easy. Because domain is domain of this intersection, domain of this. You compute the domain separately, one by one. Domain of f. You remember the classical three restriction that we have to determine the domain. The assumption, the supposition, is that the domain of the any function that you face is all real number. However, except restriction, and we have restriction in three scenarios, 1, 2, 3. The first scenario is with this division, the expression in the bottom, non-zero. Okay, by the way, this is the case. Because another scenario is when you have a square root in the top or in the bottom, but in this example, we have no square root. So in this scenario, let me repeat because it's important. It's non-negative, the expression inside, because I want to avoid imaginary number, and here is positive. Guys, try to memorize, or not memorize, copying one important piece of paper. This because we use it every day, no? So now, for example, to determine the domain of f, you take the expression in the bottom, que es this, and you copy x plus 3, no 0. And therefore, x is no negative 3. Negative 3 is a bad guy, and this is logical, because negative 3 plus 3 is 0, and division by 0 to be undefined. Likewise, domain of g is you take the expression in the denominator. I don't care the expression in the numerator. No, only denominator, because the action is you need to avoid que is 0. And the answer is no negative. Okay, you compute the domain of f and g separately. Now this is an important moment, crucial moment, crucial, important. Now I need to put the intersection, both situations. Let me explain. Remember, A is like a compound inequality. We ending graphically to understand the compound inequality. This is the line I want to do as the all real number line. This is all real number line. From positive infinity, negative infinity. Cool. 0 in the middle here. Not necessarily in the middle here. Because the point is -2 and -3. -1, -2, and -3. I investigate. Okay, in -3, we have a hole. We have a hole because it's to be undefined. And in -2, we have another hole. We have another hole. It's the only restrictions in this function. And the rest is okay? Yes, the rest is okay. And how you indicate that? Well, you indicate like that. That part is okay. Continue forever to infinity negative. The part in between -3 and -2 is okay. And here is okay. Okay? So how we express it, this domain together? Well, domain of the function f plus g is expressed in the test. Always I ask you in interval notation is from negative infinity, comma -3, okay, by the way is this piece, union from -3, comma -2, que is that piece, union -2, comma infinity. 3 pieces we have in the domain. And this is the final answer. Cool? Okay, we have to answer, guys. The first answer is expression, bang, and domain. State is domain. This is a classical. So you forgot domain, 0. So you forgot the expression, 0. So you forgot both, double 0. Clear? Let me try to do very, very quickly one more example, taking advantage the function f and the function g, but now I want to discuss in division, because division is special. Division is special because division, you know, include another restriction, no? So now suppose que I want to do exactly the same, but division. F division by G of X. Expression and domain. Okay, expression is relatively easy because you are dividing F, que F is 1 over X plus 3 divided by X over X plus 2. And leave it like that. Of course, no. You are doing the division. You copy the top part exactly the same. And you copy now the bottom part, but reciprocal. You put X plus 2 over X, only X. So the final answer is X plus 2 times 1 stays the same. X times X plus 3. If you want, not exactly mandatory, you apply distributive here in the top and the bottom. It's X squared plus 3. Boom. And this is the elegant, decent final answer expression of the division. And state is domain. Well, domain is similar, except that you need to consider the 0. Okay, you need to consider. Remember, domain is in the division is domain of f intersection domain of g. I did that. Okay. Now and or intersection when the g of x is not 0. It's not 0. So this introduces a new restriction. A new restriction is when the g is 0. And who is g? Well, g is this. and g is 0 at x equals 0. So actually, in my problem, I introduce a new hole here and 0. So we have no 3 interval, we have 4 interval. We have this interval. Okay, now you copy here, intersection. Let me erase that part. And these pieces from -2. The order is not important. -2, comma 0, and 0, comma, well, let me try to do using my best. That part is the same, but this is different. This is -2, 3. This is -2, 0, and union 0, comma infinity. And this is the domain for the division part. Is clear the idea or is confusing? Tell me something.
It's clear.
Okay. Now the last combination of the function is composition. Composition. So function composition, composition of function, function composition, functions composition. This is confusing. Composition. Very confusing. We have two functions or three. But let me explain to the famous f and g, and we put together using composition. It's a new idea. Very important, very important, very important in calculus. And what is that? Well, the symbol is F0G. This 0 indicates composition. And what is the idea behind composition? Well, is okay, we have two functions. This is the first one, okay, is the innermost, and this is the outer. And the connection is like that. Look, you copy the outer bracket and you put inside the inner. I don't know if it's clear or not for you this notation, but this notation is equivalent to this notation. So you plug in, let's see in the example now. You have one function inner, and you put the inner totally inside the outer. It's a composition of the function. Now, it's important to say something. It's important to say, okay, the ordering is extremely important. Okay, so now, of course, if you, in general, in particular, no, but in general, yes. The composition in that order is not equal the composition in this order. And the student that don't know anything, because I teach in this several times and the student don't respect something, this 0 believe que es multiplication. No, it's composition. Okay, it's composition que es one function inside another function. So in general, no equal. In one particular example, maybe yes, but in general, no. Let me illustrate the idea. It's super easy. Look, you have two functions. Que es x squared plus x plus 1. Semicolon. We have another function que es g, que es 2x plus 3. I want to find, for example, in the test, ask you find f composition g in this order. We are doing both, but we practice, no? Then you take this expression, okay, the innermost, g is the innermost, and you replace in f, but in any place of x, you replace by the expression 2x plus 3. So actually, we have 2x plus 3 square plus 2x plus 3, no square, linear, 1 exponent, que es invisible, plus 1. And leave it like that? No, you apply some algebra. You FOIL here, and the answer, remember, quick FOIL is square the first, is 4x squared, plus multiplication both an extra 2 times 3 is 6 times times 2 is 12, plus square the second is 9. 3 squared is 9, plus 2x, plus 3, plus 1, because the only thing I did in the last part was remove the parentheses. Now combine later, why not? To express it not too long, so express it more condensing, and you see that these and these are like term, get 14, and this, and this is 13. Okay, and this is expression que corresponde with the composition. Okay. Let's do in backward. By curiosity, let's do in backward. Backward is, suppose I want to find G composition F. Oh, this is different. Yeah, I want to illustrate clear. It's different. Okay, now the thing we're doing is, Professor, will you give it extra time for the student to complete the test too? Yeah, bueno, but okay. We negotiate that. O sea, the official due date is Friday. Okay, by the 99% of the time. So you have some issue, you have one particular situation. This is not the place to talking to me about that. You email me private and you explain me the situation. See, I understand. I give you more time. Okay, but I give you more time in the test 1 because I understand the new student that don't understand very well, but on the test 2, well, maybe, but the 3 and 4, no. Okay. Okay. So any issue, you email me today. Okay. Now the composition in the other direction. The composition in the other direction is like that. I see that the innermost function now is f. You take f and substitution replace here in the x place here. So 2 times parenthesis x squared plus x plus 1 plus 3. Do you understand the thing I am doing or no? Okay, now, well, leave it like that. No. At least you remove the parenthesis, 2x squared plus 2x plus 2 plus 3, get 5. And the answer is 2x squared plus 2x plus 5. It's a composition. Okay, so I propose you start doing the review. Because in the review you see another new, not totally new, but another new properties. Okay, I want to discuss it in detail. Okay, so now I can erase the board. Yes or no? Okay.
Yes.
Okay. Pay attention. Any question, you let me know. Guys, I enjoy answer the question. Any question is good. Okay? My objective is that you be strong to take the test. So you evaluate with me now, take advantage. I am your teacher. Okay? Any question you have. So now, let's move on to the first page of the review package. Oh, no. Wait, stop. Fall 2022, Mac 1105, chapter 2. Wow, this is my first page. Okay, review for the test. I sent today in this email. I don't remember. Okay. Listen to me. We cover question by question between today and Friday. The first question is weird. It's about one property that we don't study before in the lectures, but it's super easy to understand. It's increasing, decreasing. When the function, let me try to explain the theoretical part behind this. And immediately we apply in this example. Okay, by the way, it's 2 examples. One function, this is x, this is x, this is x, this is y, this is y, and this is y. One function is increasing, look like that. Why because you pick, for example, 2 point arbitrary, x1, x2, and the corresponding y, y1, y2, and the situation we have is you take x2 bigger than x1, and this situation implies that y2 is greater than y1. It's because the function is increasing, because it's going up. Okay, one funny way to understand this, you believe that our curve is a roller coaster, and the car and the roller coaster travel always from left to right. See, the car and the roller coaster go up, it's increasing. Make sense? Increasing function. And maybe this behavior is specifically in one interval, not in all real number. Let's see, I don't know. For example, decreasing is when it's going down. You see now? This is decreasing by the same reason. You pick 2 points, x1, x2, y saw que y1 is bigger than y2, entonces the y is decreasing, o sea, y2 is less than y1, is decreasing. Y another possibility is to be constant. To be constant is when it's totally flat, when it's horizontal line. In one interval, not always, but in one interval, maybe it's flat. And when you pick two different x values, x1, x2, the y value is the same. y1 is equal to x2. So you replace y2 equal y1 specifically in this interval, and it's a constant function. Okay, entonces apply the roller coaster idea. When the roller coaster travel from left to right and going down, it's decreasing, and the roller coaster stay at the same height, is constant. This idea is clear?
Yes.
Now we focus. Entonces one extra super sophisticated detail is that when you express it, determine the interval over the function is decreasing, increasing, and constant. Write your answer in interval notation. Important. Interval notation. Always in the test, interval notation. Are you not familiar with the interval notation? Open parenthesis, open bracket, dependency include or no the endpoint. And you separate two numbers, lower bound and upper bound. Okay? And extremely important. The thing I want to say is important. I don't know why the students make a mistake every day in this question. Why? Because this is tricky, confusing. Because, for example, let's focus in this example. This is a parabola. Let me try to do my best. This is a parabola. And this parabola is going like that. Okay, entonces one point is given here, que es 4, 0. And here, minus 4, 0. And here is 0,7 because it's on the y-axis. Yeah, I need to find the interval when the function is increasing, decreasing, or constant. Obviously, constant, and that function never is constant because remember, you analyze the roller coaster car. This is my roller coaster car. And the roller coaster car travel always from left to right. So you try in opposite direction, you are in big trouble. No, it's from left to right in the x-axis. And you analyze the behavior in the y-axis. It's obvious that in this interval, the roller coaster go up, and it's obvious that in this interval, the roller coaster go down. Everyone understand very well this. the part que the student make a mistake is when you differentiate the interval. Let me using another color. Maybe green is good. And this interval, que es x value, is increasing. So you write like that. Is from negative infinity, que is that part, to 0. Okay, important. You write in this interval x value. And the teacher, well, I remember I am bad guy in the test, intentionally give me 7 to confuse you. Okay, entonces now you always write here x value, never y value. Okay, entonces this interval que es green color is increasing. The behavior is increasing. And let me try to use another color, maybe red color. In this interval, the function is obvious, is going down, is decreasing. Entonces es from 0 to positive infinity is decreasing. Never is constant, never is flat. And get the story. Super easy. And E7 do not participate. And again, this 7 is to confuse you. Clear or confusing? Any question? Come on, guy.
It's clear.
Okay. This is Elsa, no?
Yes.
How do you feel?
Really bad.
Good. Okay. There you are, John. Don't worry for this.
Professor?
I
have a question. So what was the purpose of 0.7? Like,
is to you make a mistake. It's a purpose. There are some people, I don't know why, the tendency of the student is, no, from negative infinity to 7 is increasing. No, 7 do not participate in this game. It's 0. You travel, so the guy can analyze this. It's me. Suppose I am me. Look, this guy walking on the x-axis. Yeah, I go from negative infinity to positive infinity. When you move in, I see when you travel, tuck. For the green interval, the function is increasing because the y and the function is going up. However, when you travel, tuck, for the red part, it's obvious it's decreasing because the y value is going down, the roller coaster car is going down. This is clear, and this 7 is totally irrelevant, stupid information I put here to confuse you. And the student gets not clear and the concept, make a mistake. Cool? Mister?
yes.
What's your name, Mister?
Apolinario.
Apolinario, the famous Apolinario. Okay, Apolinario, you are a good student. Try to do your best, right? But I want to see your face in any lecture. Good? Okay, let's do it in the second. The second, let me try to do one more clear sketch. Look like that. X, Y. Okay, it's something like that. Approximate. But the only information gets given is this point, que es negative 0.5, and this point is positive 0.5. I need to determine in what interval is increasing, decreasing, or constant. Well, constant, no. Well, no, never, but on this example, no, because constant is flat. I don't see any flat. I see it's going up, going down, going up, going down. What is the interval que on your opinion? Remember, we using always the x value. You're using the y. Well, the y value is not given here. I am good guy. Suppose I give the point is 2 and this is 1. You know, okay, these 2 and this 1 do not participate in the answer. Okay, this point is 0.5, 2 and this point is minus 0.5, 1. You know that the y value do not participate. Entonces now, in what interval you see that the function is decreasing, increasing, and constant. I need help. Come on, participation.
From the minus infinity to minus 0.5 is decreasing.
Okay, stop here. She's right. She said that from negative infinity to 0.5 here is decreasing. So you copy here. Negative infinity, comma, minus 0.5, always parentheses. I want to explain why always parentheses, but no now. And that's it. It's decreasing only in that piece.
No.
Oh, no. No. And what other piece is going down? Decreasing?
From 0.5 to infinity.
Good. Positive infinity. So we have two intervals in which the function is decreasing, sorry. And you write in this elegant way. Two intervals connecting by union gets u. And that's it. And what about increasing? You see something increasing or no?
Yes.
What interval? What interval?
From minus 0.5 up to positive 0.5.
Super. Is minus 0.5, comma, positive 0.5. This is no point, it's an interval. It's increase. The function is going up. The y value is going up. And constant, never. The reason that I do not include this endpoint is because the behavior of the endpoint, suppose this point, the function is now decreasing and stop decreasing, not decreasing anymore, and now start increasing. So what is the behavior of this? Belong to this or belong to this? No, this point is special, and this is called local minimum. Likewise, this guy is a local maximum. You see clear in calculus, guys. In calculus, you see, you study in detail minimum and maximum. This is the most important thing in calculus. Okay, any question about decreasing, increasing, or constant function? No? Remember, there are many ways to study. You are doing your homework in Alex. You see example of this. You take it, if you have time, the pretest. I don't give credit for the pretest, but pretest is like a trial of the test. So if you are doing the mess and the pretest, no problem. I understand very well, but you are ready to take the test and get good grade. Any question in increasing, decreasing, and constant? No problem. Everyone understand very, very, very well. And remember, I don't want to see y value in the answer. I see y value in the answer, I put 0 automatically. I don't get anything because you don't understand anything. Okay, let's move on to question 3. Question 3 is a piecewise function. Let me copy again one more time. F of x is equal, open, big curly bracket. We have 3 pieces, minus 3x plus 2. This piece is valid if x is less than negative 2. And x squared plus 1 if x is in between negative 2 and 3, but not include 3. And the last piece is 4. It's a constant function. Remember, this is y equal, this is y equal, this is y equal, and this is obvious que y equal because it's f of x. You know very, very well that y and f of x is the same thing. This is function notation and this is no function notation. And frequently, the function notation is very, very useful to understand the functions. If x is greater than or equal 3. Okay. And they want no do the graph. No. Sorry, no. It's only evaluate. Evaluate at. Entonces, let me try to understand this. I do my famous all real number line. Yeah, I realize okay, we have n minus 2, this is 0 in the middle, 1, 2, and negative 2. We have one transition. In 3, 1, 2, 3, we have another transition. Okay, so let me use in 3 different colors, maybe blue, maybe red, no, red, red, and green. I don't know, I like color, no? So you don't like, no problem. When you have practice, you don't need the color. And for example, you evaluate the first point is negative 2. No, negative 2 lie here, negative 2. Oh, it's complicated, guys, because negative 2 is in the transition. I don't know if it belongs to the blue bar or belong to the red part. What do you think? And what is the key to help me to understand this equal sign? Where is equal sign? Equal sign is this, and negative 2 is here and here. However, we have no equal here and equal here. This is obvious. When you evaluate f and negative 2, you select, this is selection process, the second piece. And you plugging in, you put this symbol to indicate such that I'm plugging in negative 2, x equal minus 2. And the rest is basic arithmetic, is minus 2 squared plus 1, and minus 2 squared is 4, and 4 plus 1 is 5, end the story. Boom, final answer. Okay. Important. And the piecewise function, we have a process of selection. And how you select, you try to find where lie negative 2. Negative 2 lie in the blue interval, in the red interval, or in the green interval. Oh no, lie in the red one because it's equal, right? Do you understand this or no? Yes or no? What happened, guys?
Yes.
Okay, let's do it next. Next is evaluate the function at, let's see what is the next value. 0. Evaluate at 0. So now again, the process of selection. What piece you select? Number 1, number 2, or number 3? 0. 0 and x. This is the x axis. 0 here, right? What piece you select? Tell me. Are you there? Or you are sleeping? The second. The second. Okay. One more time. I select x squared plus 1. But now you evaluate at x equals 0. The 0 squared plus 1 is 1. Boom. Final answer. Any question? Now evaluate in negative 3. Let me try here. Evaluate at negative 3. Where is negative 3? Oh, negative 3 is here. And negative 3 belongs to the blue. So you select the blue expression. que es minus 3x plus 2, and you evaluate at negative 3. Okay, entonces negative 3 times negative 3 plus 2. Negative 3 times negative 3 is 9, plus 2 is 11. And this is my beautiful final answer. Do you follow me? It's easy. It's only interpretation, this. Okay, and phi, no? What's the next? Phi. F evaluating phi. F evaluating phi is, well, phi here. This is 3, 4, 5. Phi belong to the green part, and the expression can represent the green part is just 4, que es a constant, and this expression do not depend on x, so x do not participate because it's constant, and the answer is 4. Do you understand this idea or no? Do you understand this or no? Confusing? Confusing que sometimes happen que we have a functions que is a constant, and when this is a constant, it's just a number, and just the number do not depend on x, so this phi do not participate in the game of the plugging in. For example, next is in 3, f evaluate 3. So again, intentionally, of course, I put a transition point, and you need to interpret it. See, the 3 belong to the green or belong to the red? Who help me?
Belong to
To
the
the
green.
green.
To the green. And the clue that belong to the green is because this equal sign is here, not here. Bueno, entonces the question que fly in the air is, bueno, professor, yeah, I have equal sign here. Is possible? No, because this is a contradiction of the definition of the function. Remember, one value of the function accept only one value in the y. So you have, for example, equal is a no function. This is no function because x equal 3 is associated with the two different expressions and give me two different answers. Wait. Entonces, another question, professor, I don't understand. It's possible in another example. Can you have no equal in both? Yes. Entonces, the answer of f evaluatory to be undefined. Because I try to find x equal 3, I don't found. Entonces, always que es undefined. Pero no, we come back, restore of the original problem, que es equal 3. And equal 3, yes, it's defined. And by the way, the answer is 4. Cool. Everyone follow me?
Yes.
And now evaluate negative 4. It's the last one. This is a typical question in the test, guy. So what the next negative 4 is here. And we have a process of selection. What piece you select? The first, the second, or the third? What piece you select? I will show me. The blue. And the blue is minus 3x plus 2, no? Evaluate, this is the symbolic convenience way to indicate plugging in x equal minus 4, no? Minus 4, right? It's minus 4. So now it's minus 3 times minus 4 plus 2. This is 12 positive plus 2, 14. Boom, final answer. Any question? What part you don't understand? And this easy, straightforward question. Piecewise function. Do you understand very well how this is confusing? I put confusing, I put tricky, and you need to be careful when it's equal, no equal. And the transition point is the most complicated. You need to understand if it belong to the blue, belong to the red, belong to the green. I don't know. No problema. You understand very well this. Okay, Let's do one more about piecewise function, que is do the graph. Remember, we can do the graph en Desmos o en paper. We are doing both. I don't know. You prefer actually in the real life we are doing in Desmo or no? Be honest. This is no cheating. No, Desmo is a calculator, free for everyone. You open that and you use it. The function in the number 4 question is f of x equal big curly bracket minus 3 plus x. Wow. If x greater less than 1, and just for que se constant, if x is greater than or equal 1. Entonces, I did not evaluate. No, the question 3 was evaluate. The question 4 is do the graph. The answer I need is the graph. Entonces, now, what do you recommend me? Doing by hand, doing in decimal, or both?
Both.
Both. Okay. Both. Okay. Okay, let me try. This is our, suppose in the piece of paper, this is my rectangular coordinate system. And remember, we taking the first piece, that piece. Yeah, I copy separately. Y equal minus 3 plus x. Yeah, I try to do the graph of this. Well, this is confusing, professor. Much better to write like that. X minus 3. Yes or no? Wow, because I want to compare with the equation of the line, I very well know is this. And you believe, you realize que b is negative 3, que the y-intercept, que by the way is the point 0, minus 3. I plot that, boom. And the slope is 1. Positive 1. See, the slope is positive 1 is because from that point, I'm moving 1 over and 1 to the right. And you get the second. And we are doing the line. 45 degrees. This is the graph of this piece. And that's it. The second piece, well, second piece is this one, que is a constant function. So you copy y equal 4. It's a constant function. A constant function, I know very well, que is horizontal line. Horizontal line passing through 4. Say horizontal 0 degree. And my rule 1, 2, 3, and 4. This is 0 degree. Okay. This is y equal 4. This is y equal minus 3 plus x. Okay. Now look in the condition. I focus in the condition is 1. The transition is in 1. Okay. So now I know the teacher explained me que in the transition we are doing the vertical line, vertical line, because the equation is x equal 1. It's vertical line. Vertical 90 degree. 90 degree, 90 degree, 90 degree, 90 degree. In 1. However, I am doing the convention is dotted line. Because it's just imaginary line que split the plane XY into semi-plane. Oh, entonces I have the condition before 1 and the condition after 1. Entonces, I come back to the beginning. The beginning I say, wow, look at that. The condition before one, my piecewise function original travel for the line, que es -3. So I suppose que look like that. I try to do the final answer in red color. This score continue forever in that direction, and the symbolic way to indicate this idea, you put an arrow. This is continue for negative infinity. And here we have a point. I don't know if it's closed or open. This is important detail, super important detail. And you have a discontinuous jump because we do not continue with the lines, you jump to the horizontal line. So we have another important point, and you continue travel after the one for the horizontal line. Okay, so now my red color is the only information I need to present in the test. Okay. The rest is okay. You want to erase or no, it's not important. Now, the important is what is closed and what is open. What is closed and what is open. What circle is closed, what circle is open. The circle and the above or below, I don't know. What is closed or what is open. So the circle que is located in the oblique line, not horizontal, I don't see equal sign. No equal sign here. No equal sign. And this no equal sign indicates us that this guy is open. Now, and the other, yes. This equal sign is super important detail. It's closed. Done. Now, if you want, no mandatory, you erase everything and stay only the red color. Wow, and this is my final answer. Any question? What part you don't understand very well? Clear? Guys, this is a review. Do you understand that this is a review, right?
Yes, it's clear.
To be ready for the test. Elisa.
Yes.
If you need more time, I can extend it for you, right?
Okay, thank you, Professor.
No problem. You are a good student, excellent. You prove this, and you have 6 now.
Okay, thank you.
Okay. So let's do the same problem in decimal. Yes or no? And we compare.
Yes.
Let's do it. Decimal now. Okay. Do you see decimal or no? No?
Yes.
Okay. Let me call example 3. For example of the review, maybe. The name one, Maria Jose. It doesn't matter. Of review. Okay, enter. And you see okay, the next, like you can drag if you want. You put in any place you need. But immediately when you press enter, put another line that is connected with the folder. And you copy each piece one by one. I forgot. The first piece is -3 plus x, no? -3 plus x, yeah. -3 plus x. -3, you put a y if you want, but not necessary. Y equal -3 plus x. Okay, and this is a line, but this is a full line in both directions. However, we have restriction, and the restriction is you put the restriction or the condition, sorry, or restriction is okay. It's when the x is less than. X is less than 1. Boom, and you see one piece of the line, not the total line in both directions, only one piece. Now, the second piece is y equal 4. Y equal 4. Okay. It's a horizontal line. Look in black color. Let me use in black color. The color that you prefer, but black is okay. I don't know why I prefer like black color both. I put a restriction. The restriction is open the curly bracket. This is in the language of Desmos, guys. Curly bracket is a restriction. Desmos, the engineering computer can create Desmos using this symbolic way. Entonces, x greater than or equal, less than, no, greater than or equal, bam, bam. Well, that's it. No, I forgot the most important part. Is the point. The point is we have two kinds of point. One, using our common sense and imagination. We have one point here down. Is the point? Let me make. Let's see in this one. Es 1 comma negative 2. I guess so. 1 comma negative 2. Oh, pero no en red color, en black color. And this point is closed or is open?
Open.
Open. So the way to indicate open is here. Because in another line, unfortunately, we need to open another point. Is the point 1,4? I guess so, right? 1,4. 1,4. It's obvious. Okay, black color again, and this is close. That is my final answer in Desmos. I save. Entonces I close everything. If you want, you put on enable or no, either way, and you save, and you put a name. This is review. Or test number 2. Well, I'm teaching several classes, entonces it's important for me to indicate Mac 1105. You save. And you save in your own account in the cloud, not in your computer. And you see my name here because I create account. No? Okay. Okay, let's do at least one more example of the review, and that's it. How do you feel? How do you feel?
Good.
Okay, do you see now the whiteboard? Oh no.
Yes.
Let's move on. Let's move on to the next question. No. Next question is using also the rectangular coordinate system. Okay, I know. Okay, this test is hard. A funny thing. In the class in person before the pandemic, I say in a funny way, cause in this test, sometimes I need to call 911 because some students have heart attack. Because I don't know why the students don't understand very well the graph. No? Entonces now, okay, and this in the class in person, you have no Desmos. Okay. So now number 5 is different, a little bit different. Is do the graph of the function gets given, que is f of x is equal minus x squared plus 4. Do the graph of this. And complementary, find y in a set and x in a set. Okay? So this is a classical question about transformation because you need to know You need to know okay, this function is given in this question is come from for the basic function que es the function f of x equal x squared, que es de parábola, ¿no? Es de parábola. Es de parábola. And the parabola I know very, very well. I remember que look like that, approximately, you know, roughly sketch. Entonces my question is, how many transformations you can see? In what order you apply this transformation? How many transformations you can see in the expression, in this expression, in this expression? And in what order? What is the first? What is the second? What is the third? See, we have 3 or 2. Do you see transformation? Yes or no? Transformation, transformation, transformation. Do you remember transformation or you don't remember transformation? No idea?
Do not. Yeah, no, don't remember.
Say again?
Don't remember.
2. Don't remember. Wow. Wow. Well, let's do it quickly. You try to remember. Number 1 transformation is vertical shift. And vertical shift is you take the function and you add in one number. Suppose 4. This is vertical shift. The parabola, that parabola is open up, is moving 4 units upward. This is vertical shift. I suppose these 4 represent vertical shift. However, we have reflection. We have reflection because when you replace f of x and you put a negative in the front, because this scenario, so you put a negative here, this negative indicates reflection. But reflection about x-axis. Okay, you need to remember the different kind of reflection. See, the negative is outside, a reflection about the x-axis, and see the negative is inside, is reflection about y-axis. This is a y-axis reflection. Likewise, horizontal shift is when you are doing something but inside the parenthesis, like that. So this is when it's positive, it's up. When it's negative, it's down. Positive up, negative down, negative. And here is moving horizontal. When it's positive, it's left. When it's negative, it's down. It's right, sorry. Do you remember this or no? You don't remember that? It's hard to remember that. It's almost intuitive idea. Yes or no? Entonces, how look like our parabola after the 2 transformation? Because I identify that we have reflection. See, we have reflection is because this parabola is going down like that. This is minus x squared. I did this transformation using minus. Guys, this is easy. This is not science fiction. This is straightforward. And plus 4 is vertical shift for unit upward. So our parabola is moving. Here is 0, 4, 1, 2, 3, 4. I'm moving down like that. This is the parabola minus x squared plus 4 after 2 transformation. The transformation from this to this was reflection. Transformation 1, reflection. About, of course, x-axis. And the transformation for this to this, transformation 2, was vertical shift 4 units up. This is clear or no? Come on. I need interchange. Yes, Emily say, Emily is always understand. The rest of the tune.
Yes, clear.
Clear, okay. But you have to remember, you understand now, but if you don't retain the information. Entonces, what is the reason that you go to school? Okay? Extra thing that we need is the intersect. And the intersect is super easy. Because what is the formula? What is the formula? What is the formula to compute the y-intercept and x-intercept? Y-intercept, the formula is using function notation, evaluating zero. X-intercept notation is f of x equals 0. Let's do it. Let's do it. Let's do it. You have the function. The function that's given in my problem is minus x squared plus 4. And you evaluate en 0 es minus 0 squared plus 4. Es obvio que 4. And you plot the point is the point 0,4. Because the supposition for finding the y-intercept is supposed que x is 0 and you get the y value. And you plot this point, que sí. It's obvious, no? We predict mentally this. Now, in the x-intercept, well, you copy the function expression minus x squared plus 4, and you enforce it to be 0. And when you enforce it to be 0, in this moment, you have a quadratic equation. Super easy, elementary quadratic equation. And you isolate x squared. You move to the other side. You apply square root both sides. And it says x, and it says 2 plus or minus. Wow. So we have two solutions. The solution are 2, 0 positive and minus 2, 0. Entonces you plot that point, que is here 2, 0, minus 2, 0. Wow. And my parabola look like that. Look. Okay, it's important to say something. The parabola is a smooth curve. So I try to do my best. It's something like that. It's a smooth. So now, parabola is like that? No. It's a sharper point. No. It's a smooth curve. Guys, too much. Too much for today. We continue Friday. The review parts. Okay? 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 See you. Have a nice day.
Thank you.